we will wait another 1 minute or 2 minutes and then get started. Okay, let's get started. Hello, everyone. This is a TCPM working group meeting. Please make sure you are in the correct room. And my name is Yoshi, one of the co-chair of this working group. And then Michael is online. Hello.
Hello.
Okay, moving on to the next slide. So this is user note well. I think you are already familiar with this one. But this is just a reminder of how to participate in IETF meeting. If you have any concerns about it, please check this one very carefully. And in a nutshell, you can find the same document on IETF webpage. So if you want to read through this one, please check IETF webpage. And this is logistics. We have one note taker. Thank you so much, Richard. And Michael will take care of Java. Thank you, Michael. And this is just a short reminder. When you submit your internet draft to this working group, please make sure to include TCPM in your draft name so that we can track the status of your draft. We appreciate your cooperation. Okay, this is agenda for today's meeting. First, we started from working group status. Then we will discuss working group document. First one is proportional rate reduction. Neil will talk about it. And next one is TCP ARC rate request option. Carlos will talk about it. And after discussion of working group documents, we will discuss individual documents. The first one is TCP reset diagnostic payload. Med and Till will talk about it. The next one is source buffer management. Stuart will talk about it. And if we still have a time, Michael will talk about the behavior of cross for TCP socket with non-zero linger time. So that's the current plan for the agenda. Any comments or suggestions to the agenda? Okay, moving on to the next slide. So currently we have several working group documents. The first one is accurate ECN. We have discussed this draft for a very long time, but finally we are going to finish this document. The current status of this draft is RFC editor queue. So it will be published very soon. Thank you so much. And the next one is 6937 base draft. The chairs are thinking that this draft is really close to conclude the working group last goal. But in any way, we have a discussion of this draft in this meeting. The next document is generalized ECN. This document has been around for a long time, but this is because generalized ECN depends on accurate ECN. So we have waited until accurate ECN has finished. But now accurate ECN has finished. So we are thinking about proceeding this draft, which means initiate working group Rust code very soon. That's the chair is thinking right now. The next one is accurate request. We will have a discussion in this meeting today. And the next one is Go Stack. We don't have a presentation in this meeting, but I think chair is working on revising this draft. So let's check once new version has been submitted. The last one is TCP EDO. In the last meeting, we have some discussion on this draft as well as some implementation status. And then there are several opinions. And then that currently the chair is thinking about what's the best course of action of this draft. So we still need more time to think about it. That's the current status of this draft. So that's all. That's the current status of all working document we have. Any comments or suggestion or question to the current working group documents? Okay, moving on to the next slide. So this is the last slide. So this is a slide Richard gave to chairs. So according to Richard, it took 4,828 days since the first submission of accreditation draft to the final version of the accreditation draft. So it took 13 years, very long time. We really appreciate the patience of the authors. Thank you so much. And this seems to be a 14th longest RFC life cycle amongst all IETF documents. That's great. Thank you. But okay.
So this includes the individual draft, right? Not only the working group.
It does.
Yeah,
I'm not so sure if this is something to look up for.
It actually goes back even further because there was before the re-ECN stuff, right? Before Connex was created, and then it wasn't Connex and so on. So like, if you want to take it all.
Thank you. But I personally believe that's the reason why it took so long is the importance of this draft. So accreditation is a very important technology for current and future internet. That's why many people have many opinions, and that's why we have a long discussion. But in the end, we have a very good document. So we really, really appreciate everyone who contributed this document and built this important technology. Thank you so much. Okay, this is end of my slide. Any final comments? Okay, then moving on to the working group item discussion. Neil, are you ready?
Yes, can you guys hear me?
Yeah, let me try to share slide. Oh,
should I ask to present slides?
Yeah.
Okay.
Okay. And also I give you the slide control.
Okay. Let's see. And how do I
Yoshi,
tell it
do
to...
you need to stop sharing slides? I still see the
Oh, maybe I
accreditation
can click the
slide.
change deck. Or I'll click the change deck button. Let's see if that works. There we go.
Yes.
Okay, great. All right, so thank you very much. So I'm going to talk today about proportional rate reduction for TCP. This is joint work with my colleagues here, Matt and Nandita and Yu Chung. So just a quick overview for everyone as a reminder. So RFC 6937 PRR was published back in 2013 as an experimental RFC. And at the time, it was only implemented by Linux. and it was implemented without rack TLP. And it's a bit of you can think of it as kind of a mini congestion control that only runs during fast recovery. And the idea is that it smoothly controls the rate at which the sender is sending while you're in fast recovery to try to gradually move the amount of in-flight data toward SS thresh so that by the end of fast recovery, hopefully your amount of in-flight data is quite close to SS thresh. And the original document had two different modes where the implementer had to pick one of the two modes, which was a little bit cumbersome. Yeah. So we started this 6937 BIS process back in 2021. And at that point, PRR is default enabled in most of the major TCP implementations. And the working group voted to revise the RFC and publish it as a standards track RFC. So that's what we're doing here. And this slide describes some of the previously discussed changes that are at this point many revisions ago. So at this point, I'm going to focus just on the changes since the last revision that we discussed in November. These changes were in response to comments from Marku on the mailing list. And if you have the PDF, you can click through and you can see the exact textual diff. Basically, we've gotten to the point where between revisions 12 and 13, where 13 is the current revision, we basically really only had one change, to change the word pipe to the word in-flight. So hopefully we're approaching convergence because the changes are getting smaller here. So previously in revisions 12 and earlier, we used the term pipe because that's the term that's used in RFC 6675, I believe. But then Marku nicely pointed out that really pipe is from a very specific algorithm, and we want PRR to be independent of that algorithm. And in particular, we definitely want PRR to be usable with rack TLP, which is a different algorithm than the algorithm that produces the quantity called pipe. Marku suggested that we basically tighten up the terms that we're using and be clear about the words that we're using here for this quantity. So what we've done here is we basically changed the word pipe to the word in-flight. And this was a proposal that we discussed as something that we might do back in November, and we didn't hear any objections, so we went ahead and we made that change in revision 13. So just to give you a reminder here, the rationale for switching from pipe to in-flight was to clear up this ambiguity I just mentioned, and we figured in-flight would be a safe term because that's a widely used term in TCP implementations and documents and papers. Both Linux TCP, BBR uses that, rack TLP uses that in passing, the Prague draft uses that, and we figured there shouldn't be any confusion because in-flight is not a term that's used anywhere currently in any of the previous loss recovery or congestion control RFCs that are previous standards, so there shouldn't be any conflicts or ambiguities or confusion. So the specific changes we made were number one, in the definition section, we added a definition for this in-flight term that we're using. And in short, it's the data sender's best estimate of the number of bytes outstanding in the network. So it's very similar to the pipe concept. It's just this is a more general definition. But we do mention that if you're using 6675, then you can use the pipe algorithm to compute this quantity. And then the second change we made was just going through the document and replacing occurrences of pipe with analogous phrases using the word in-flight. and you can check the diff for the exact changes we made. And that's it. So yeah, so we are. I just wanted to say that we're interested in moving the discussion along and seeing if folks think the document is in good shape to move to the next phase. And also, of course, we're open if there are any questions or suggestions.
Any questions?
Richard from the floor. Just wanted to say that yes, I like to have a different terminology here in this draft. That's a good change. So I support this. And yeah, please move on.
Any other comments? So far, I'm just seeing all positive comments. So I think, we are about to close the working group Rascal. From Chair's point of view, the changes, Neil talks about it totally makes sense to me. So it's totally fine for me as a dog shepherd. So if people don't have any objection, we are going to conclude this working group Rascal and submit to IESG. Of course, no, we are going to make sure final check on the mailing list. But in this room, if anybody has some opinions, this is a good chance for you to speak up.
Yeah, Mohit from NITK. Just 2 points. I agree. This is a very good change in the terminology. So yeah, positive one. And just wanted to let the team know that we have implemented this new draft in NS3 network simulator. So if anybody wants to test the old PRR, which was 6937, and the new one, that's possible to do. Just wanted to give a heads up.
Thank you.
And Gori Fair is simply asking who's implemented this version of the spec or tried to, just so that we have a list.
You want to ask us a poll?
I'm just asking for comments on the floor.
Okay.
So FreeBSD has the automatic change between the different behaviors for, I don't know, 3 years now. So quite a long time.
So yeah, Linux has had something that's very similar in spirit to this for about 10 years. And then this exact logic for, I think it's 4 years or 5 years. I can go check. It's on that order.
Gori and Richard, you guys in the queue. Okay. Okay. So I think in this room we are reached to the consensus. We will make final check on the mailing list, but I think this draft is ready for submitting to IESG. That's the kind of thinking of the chairs. Michael, do you have any comments? Okay, sounds good. Okay, then we will go in final announcement on the mailing list. Thank you, Neil. Okay, moving on to the next one. Carlos. Okay, so let's get maybe this one. Oh, who is? I don't have a share. I cannot share slide. Who can have a control? Michael, do you have a control? So
I'll try quitting and see if that helps.
I don't have a slide control. Let me check. Michael, can you share slide. From my side, somehow. Sorry. Why I cannot show the slide? Michael, can you show slide from your side?
Let me see.
Okay, thank you.
Uh,
Now okay, now you can control that one.
Okay, thank you. Okay, hello everyone. My name is Carlos Gomez and I'm going to present the last update of the draft entitled TCP ACK rate request TAR option. My co-author is John Crowcroft. And first of all, let's take a quick look at the motivation for the draft. Delayed ACKs is a widely used mechanism which is intended to reduce protocol overhead. However, it may also contribute to suboptimal performance in a number of scenarios, such as so-called large congestion window scenarios, meaning a congestion window size much greater than the MSS, where saving more than one of every 2 ACKs may help improve performance, and so-called small congestion window scenarios, meaning a congestion window size up to the order of about 1 MSS, where delayed ACKs may incur too much delay, may limit congestion window growth, and so on. So this is the main format for the TAR option. There is the R field, which indicates the ACK rate, which is requested by the sender, meaning after how many received data segments the receiver is requested to transmit an ACK. Currently, the maximum value for this field is 127, and there's the special case of R equal to 0, which would be the request of an immediate ACK while keeping the steady state value of R. So on the status of the draft, it was adopted a couple of years ago, and today I'm presenting revision 07, which aims to address the comments that were received in the last meeting, which were mostly on the topic of the issues that may arise with sparse ACKs and how to handle those. So in order to, with the aim to capture the feedback that was provided in the last meeting, we have provided some updates in the document. The new text is in red, and there's some updates in section 3.1, which describes the sender behavior. There is some new text, which would be that a TCP sender should only request an ACK rate greater than 2 if the expected time between consecutively received ACKs is smaller than 1 millisecond, or if the TCP sender uses pacing. Then in section 5, which already existed in previous versions of the draft, which is entitled Issues of Stretched ACKs, we have added that the impact, which is increased TCP sender burst size as a consequence of stretched ACKs, may be inflicted also on other flows. And in subsection 5.1 on sender burstiness, we already had some text explaining that TCP sender may use TCP sender pacing to mitigate sender burstiness due to stretched ACKs. However, according to the feedback we received on the other changes, we have increased the requirement level from may to should. Then we also received an IANA early review, and there is one comment with some minor impact on the draft that will be applied in the next revision, which is that the IANA consideration section should be updated to indicate that the TCP experiment ID assignment has already been made. So you may recall that long ago, when the document was actually an individual submission, there was already an assignment for the experiment ID for this option, which is 0x00AC, which somewhat tries to allude to ACK or acknowledgement. Okay, so about the next steps for the draft, the authors consider that the recent, the later revisions of the draft, the extent and the amount of updates is kind of decreasing. The document seems to be getting somewhat stable, and we were wondering whether the document might be getting in a state like sort of ready for working group last call. So that would be my last slide.
Any comments, questions?
I have a question or remark. Some TCP implementations at some time use SYN cookies for connection establishment, and this is a very small space they have. So it would be very useful if the client with the third leg adds this option once it was negotiated, so that the server can learn that the client supports this if he can't remember through the handshake.
Sorry.
Maybe Michael, you might need to get close to Mike a little bit more.
Can you hear me now?
Mm-hmm.
Yeah.
Okay, so some TCP implementations, at least at some point of time, use for the connection setup SYN cookies. So they don't store the state. And they have only a very limited amount of space to store features like, does the peer support SAC or does the peer support TAR? And a way around this is that the client, so once it's negotiated in the SYN-SYNAC, on the third leg, you indicate the TAR option and say send an ACK now. So the server can learn this from the ACK if he can't store it in the SYN cookie.
Okay, thank you. Thanks for the feedback. I understand this is something we can mention. We can describe this in the document. Thank you.
Thank you.
Stuart Cheshire, Apple. This document has been going on for quite a long time. Thank you for doing this work. I think it's very useful, not just for high throughput connections. You probably remember I've talked before about the work I do with Thread and Matter for home automation that is very low rate networks and very constrained devices. So the ability to ACK every packet and avoid the delayed ACK delay is one of the big wins that is interesting to me. I think we need to move this on. Maybe it is time for working group last call, because that will shake the trees and get people to pay attention, because otherwise we might be here a year from now having the same conversation.
This is Yoshi. This is just individual comment. I have read recent version of this draft, and I think it's very good shape. But I think one minor concern, which is middle box issue. So sometimes, paths can be changed. When you negotiate the SYN packet, then you can see TAR packet can be get through. So you can use a TAR option. But paths might be changed, and then in some cases, your new path may not allow TAR option. But in new version of the draft, when timeout happens, you must attach TAR option to the retransmission packet, right? Then that means the retransmission packet after timeout never reach to the destination. Have you ever considered about this kind of situation, or this is too minor issue to consider?
Yeah, so I think we haven't explicitly considered this issue. So I believe that the document right now states that it's not necessary to include the TAR option in a retransmission. But anyway, we will give a thought to this issue and consider the alternatives, how to handle this.
Yeah, I think in the current draft, it's must. It's specified as must, I think.
Oh, okay. Well, thank you.
Okay, so what do you think? Do you want to revise the draft, or you think you are ready to working with Flasco, or you want to update new version and ask us in working with Flasco?
Well, either way will work, I guess. So one option is submitting a new version of the draft, considering this feedback from today. The other one, I understand, would be launching the working group last call and then including also the updates from today in the perhaps greater set of updates. I don't know if from the chairs you may have like some preference. For us, I guess it works either way.
Okay, but okay.
I think the suggestions were not only editorial. So if we would run a working group last call on this, you incorporate this feedback, then we would need to do another small last call after that. So I think it's simpler to get the changes in and then run the working group last call.
Yeah, I agree with Michael. I was going to say the same thing. If you can make these changes in the next couple of weeks, then we do a work group last call on the result, because otherwise you're going to get the same comments that we've already decided to address.
Okay, yes, so we will proceed as suggested. Yeah.
Thank you.
Thank you.
Cory, you want to make some comment?
Gori Fair has just as a very general comment, but it's sometimes nice to ask for people to actually explicitly review the document, so we know that people have actually gone through the whole of the document, not just approved the idea. Do you think it's worth asking the working group if people would volunteer to actually read the text and review it?
Yeah, I personally think this would be very helpful. There were some reviews for the whole document quite early, but recently there haven't been such reviews. So I believe that it would be the right time for that. Thank you.
Michael, you are in the queue. You want to say something?
No, I did, and I forgot to get me out of the queue.
Okay, Neil?
Can you remind us if there are, or what implementations, if any, are out there of this option?
Yes, so I'm aware of some prototype implementation for FreeBSD that was led by Michael. That's the one I'm aware of. Not sure if there's maybe other efforts.
Okay, thank you.
Neil, are you interested in implementing it?
Yeah, maybe. I'm not sure that I would have time soon, but I agree it's worthwhile. I'm especially interested in the small C-wind case. I think there are the existing heuristics for high-speed links might be pretty decent, but for the small C-wind case, it seems like a really nice way to signal that you really would like an ACK because your congestion window is only a handful of packets. Yeah.
Okay. And also, I just would like to check if someone want to review this document. If anybody want to volunteer, please let us know. Are you showing? Okay. Can you speak up your name?
Mohit from NITK.
Thank you.
I'm also willing to review it.
Michael? Thank you, Michael. Okay.
Thank you.
Thank you, Gares. Okay. Let's move on to the individual presentation. Michael, sorry, can you share slide again? Michael, are you sharing? Oh, thank you.
How do I stop sharing?
Why this doesn't? I see. I see. I have to stop it. Got it. Yeah. I said. Yeah. Thank you.
Good afternoon, everyone. I will talk about our draft TCP reset diagnostic payload. Today, the problem that we see is TCP connections are reset by peers for various reasons. It could also be reset by on-pod devices, especially NATs and firewalls. However, the receiver of the reset has no clue why the connection has been reset. And there is currently there is no approach to knowing what is the reason behind the reset. So this draft is basically trying to solve the problem by adding the diagnostic payload so that troubleshooting can be made much more easier. Whether the design rationale behind this is the base TCP spec anyway allows the reset segment to include data, so we're just leveraging that. And for ease of deployment by avoiding any negotiation during the three-way handshake, and we wanted to pick something which is compact encoding to signal the reason behind the reset. And we also wanted to enhance it to accommodate proprietary reasons, for instance, including human readable descriptions, as well as your enterprise vendor-specific codes. And we don't want to change any parts of the reset handling. At the same time, in some of our benchmarking, we found that middle boxes don't drop reset packets with reason codes, but we have not done an extensive testing on that. But in case if there's a harm, reset could be sent along with the with and without the reason code, just to address any misbehaving middle boxes. Yeah, so one of the encoding that we picked was CBOR. Basically, CBOR is binary representation of data. It's quite concise. It's used by several protocols within IETF. So that was one of the reasons we picked it. But we are open to other suggestions, like if you want to pick any other encoding schemes like TLVs, plain text, etc. We could even consider that. Some of the reasons why we picked CBOR was its compactness and readily available libraries. And it could be integrated with the current traffic visualization tools. It has a diagnostic payload representation as well, and it's quite easy on the CPU as well. We have good interest from Linux maintainers to implement this spec. One of my co-authors, Jason, who works in the Linux kernel space, has already done an implementation of this, and we would want to consider this draft for working group adoption.
Any questions or comments?
So Richard, I believe you will have to have a more extensive testing of the viability of additional data in a reset packet across the wild internet. We have done this early during EquiDCN, and while the majority of paths are benign, and I don't doubt that this is, it's still interesting to find or to validate that it doesn't have any effects on larger carrier networks where, for example, some kind of either the firewall is cutting away the data, the eventual payload, or not letting the reset packet through at all. So these are two things that I believe are very necessary before this work can proceed further. At least having the necessary data for that. Sure. Other than this, there has been a discussion around the encoding of it. From my understanding, I would say there is some precedence of having plain text encoding. Some very, very old legacy implementations have been doing this. I don't see a compelling reason not to continue with a short set of plain text, which can easily be extended and be human readable in a packet trace, which is probably the reason why you would be looking for this information anyway.
Yeah, I guess that decision can be made after it gets adapted, but I agree with the benchmarking. So in our test, we didn't find anything, but yeah, maybe we could explore further to see if there are any challenges.
Michael?
I have two comments. One is for the encoding, I was wondering, wouldn't it be good enough to have a 32-bit entity and an IANA registry where you first come, first serve, just register the values? The second is this intended to be presented to the application? If yes, then how in the socket API? But now, if I receive now a reset, the receive call would return -1, and Erno tells me that the connection has been reset by the peer.
Yes, since this is for debugging purpose, it has to be supplied back to the application. Otherwise,
so then think about how this could be done, and maybe also how you can send this. So if an application wants to send this when it sends a reset.
Sure.
Corey?
Strictly as an individual with no hats, but I would have thought the biggest concern around this was like the security considerations about what you're going to say about the person who's resetting, and they appear to be remarkably vague. It's like you should not disclose privacy information. Is that not a must? I mean, so I'm a little bit worried that the security piece needs to be well thought through before we go forward. Do you have more intentions to improve on the security considerations?
Definitely. I mean, if it's just the state machine or reasons why you're resetting that without providing any contact details or anything, then yes, definitely you will have to consider, because it's going on plain text, right? So, but if it is just the reasons why it got reset by your peer or by middle boxes, I think you don't have a privacy concern. But yeah, if you're describing any contact details, then, and whether the working group wants that kind of information to be exchanged, then we will have to really look into the privacy considerations, because if it's going to be sent on the internet, right, it's going to have privacy implications.
And second, I'm really curious about why you think you might need more than 256, why you kind of recommend this is less than 256 bytes, but 256 bytes is really huge. Is that, have you got thoughts for what that large area of diagnostic information might be?
Right. I mean, we initially started with that, but right, I have to put a human description string if you're debugging your applications in your own lab setup or something like that. But beyond, like, if it's deploying at production scale, we don't have a real reason, but it was just added for testing and experimentation purposes.
Thank you.
Any other comments? So my current take is you need to revise the application based on the feedback.
Sure. Thanks.
Okay, next. Stuart?
Good afternoon, everybody. Some of you have probably heard this already. I'm sorry if you're getting tired of hearing it. I'll try to go through this quickly. Bit of the background story here is 14 years ago, I was wondering why screen sharing to my Mac in Santa Cruz was so slow. And it was a low bandwidth connection, but that wasn't the problem. The problem wasn't lack of bandwidth. And I thought it was buffer bloat in the network. But it turned out it wasn't buffer bloat in the network. It was buffer bloat on the source device. Here's a picture. In the Berkeley sockets interface, the SO send buff socket option sets the number of bytes you want waiting to go out. Now, some of those bytes have been sent, and you need to buffer them because if they're lost, you need to retransmit them. So that's good. That's the blue. But the congestion control algorithm, or as I prefer to call it, the rate manager or the rate optimizer that TCP uses to decide how to trickle those packets out into the network, is holding all the red data back because it's sending at the rate that the network can carry. And in this particular scenario, when I measured it, there were 2 seconds worth of stale frames sitting in the kernel memory that hadn't even gone out the Ethernet port yet. So clearly that's not helping CPU, it's not helping throughput, and it's just adding 2 seconds of lag to everything you do. I talked with my colleagues at Apple, and 1 week later, we had checked in a fix for TCP using sockets that allowed the application to have more visibility into how much data had actually been sent and how much data was waiting. And that meant that the screen sharing server could operate with about 1 frame sitting in memory waiting to go out instead of 2 seconds worth of frames. We did a video, did an on-stage demo at the Apple Developer Conference in 2015. That video is available online in the PDF version of the slides. That's a clickable link, or you can just Google search for that. And it really made a dramatic difference in the usability of screen sharing. So good job, pat ourselves on the back. That's now the default for all applications on iOS. If you're using the network framework APIs, you get this automatically, so that's great. But recently, we were trying to make Apple TV Plus video streaming more agile. Sitting and watching a movie for 2 hours from start to finish, we kind of know how to do that. You just open a TCP connection and send the data. That's not a challenge in today's world. But skipping around random access, now the amount of stale data you have sitting in buffers really affects the usability. And this came back, and I had this kind of sinking feeling, like, haven't we seen this before? Didn't we fix this 10 years ago? And the answer is, yeah, we fixed it for iOS, but not for Linux. So that prompted me to make this effort to come and spread the word more broadly. And I want to work with all the relevant people across different operating systems, Microsoft Linux, FreeBSD, Android, and let's figure out the right way to do this and do it consistently across all platforms. And of course, in 2011, we didn't have Quick. This issue affects Quick just as well. Just because I told the story about TCP does not mean this is a bug in TCP. This is very much an architectural consideration of any networking software. Whenever we do networking, we have a tendency to stick buffers in. And if we don't think about how big those buffers are, then not surprisingly, we're not going to have good latency. We've recognized this in the network, and we're making great progress with L4S. And the effect that that is happening is it is exposing the overbuffering on the end systems. For a long time, massive buffer bloat in the network dwarfed everything else and hid the other problem areas. Now that our networks are getting down to really good, consistent low latency, we're suddenly finding that there are problems elsewhere. So this is in big letters because this is kind of my headline point. When I was a student, I remember the battles between the bell heads and the net heads about whether ATM to the desktop was the solution or whether packet switching with Ethernet was the solution. And there were lots of debates about the bellhead said a lot of things that turned out not to be true. But there was one thing they said that kind of was true, which is you will never manage to keep latency under control with a packet switch datagram network. So you won't be able to do telephony that has a good user experience or video conferencing, not just audio telephony. And they were kind of right about that we're still struggling to do a good job of that. I mean, it works. We're using it now, but it could work so much better. And we've just got used to putting up with these problems that we consider it's normal, and we've kind of become blind to them. But I think we can do a whole lot better. So this is my call. I'm presenting this in TCPM because obviously this affects TCP implementations across all platforms, but it's not specific to TCP. Quick is going to need to think about their buffer management as well. So we have a draft that is an initial starting point. We have a non-working group mailing list, so please join that mailing list and send your feedback. And we are planning to make progress and revisit this in Madrid in July and decide if this should continue as an independent effort or whether it maybe belongs in transport area or something like that. This is an interesting philosophical question which has come up here at the IETF. People tell me this is an API issue and the IETF doesn't design APIs, so just go away. And that's true. It is an API issue. It doesn't change the on-the-wire protocol. We fixed this at Apple in 2011. We didn't have to change anything about the other devices on the network. It's totally the same protocol. The reason I'm bringing it up is I think this is an architectural issue that affects everything we do at the IETF. And I think it's important enough that we as a community should solve this and have awareness of the delays caused by source buffers, because the potential it has to improve the user experience is so dramatic that I think it's important that we raise awareness of this issue that's kind of been neglected until now.
Thank you. Any comments? Michael?
So yes, it is about API, and I think the IETF can work on APIs. At least it did in case of HTTP and TSVWG, where we specified the socket API for that protocol. And having an API is very important to access features across multiple implementations, and I think this should be considered at the IETF. One example, that's why I asked the question in the last presentation, how to do this in the socket API. Write it down in the document so people can implement this, comment on this, and agree on this. Thank you for bringing this in.
Thank you.
Hi, Colin Perkins. I was going to say broadly the same thing. I've been coming to the IETF for very many years. The IETF has been defining APIs for very many years. People keep saying the IETF doesn't design APIs and doesn't do APIs. This is nonsense. We've been doing it for decades.
Thank you.
This is Yoshi from individual comments. So I just wondering, not defining API is okay, but I'm also wondering if we might want to specify how to calculate replenish time so that we can expect different platforms behave exact same way. But it is the scope of this draft or not? We just want to define API only.
Yes, I agree with both the things you said. We don't need to define a specific API for a specific library. What we do want to do is define the abstract API, which is the concept, which can be reflected in different ways in an object-oriented language versus BSD sockets. So the details are implementation specific, but the concept, as you say, we want to be uniform, and we should define a consistent behavior across all platforms and across all transport protocols, TCP, SCTP, QUIC, because there is some calculation here. What the draft currently advocates is, instead of doing it the way we currently do, which is to specify the desired backlog in bytes, to specify the desired target in time, in milliseconds or microseconds. And conceptually, what the application is doing is telling the transport stack, when you think that you're within 10 milliseconds running out of data, let me know via K-event or ePoll or whatever the mechanism is, let me know it's time to start working on generating the next batch. And that time is a function on the application side of how long it expects to take. So I keep coming back to my example of the screen sharing. If you're doing screen sharing at 60 frames a second, that's one frame every 16 milliseconds. So it's a reasonable rule of thumb that you can probably grab a frame in 16 milliseconds and compress it. On the network protocol side, there's a bit of prediction going on, and it doesn't have to be perfect. I've had some feedback from people saying we can't predict the future, and I know that. Right now, we have no prediction at all. Even an approximate prediction is better than nothing. And the prediction is based on the current data rate, we expect the data might run out this time in the future. And that can be affected by stretch ACK, like we were just talking about with TAR. It can be affected by Wi-Fi aggregation. It can be affected by pacing and TSO. So there are many factors that go into calculating when do we think we're going to run out of data to send. That, I think, is going to be an area where we'll have a lot of debate about how to nail down an agreement on that algorithm so that it is the same across every platform. Because if somebody wants to write portable application code, it doesn't help if the behavior is different on different platforms. And actually, you reminded me, part of what brought this up was I was working with Bob McMahon, who's the maintainer of IPERF2, and he wanted to add some application layer round trip time measurement. He has added that in IPERF2. And you can't measure the round trip time if you don't know, if you have no control over how long packets spend sitting in buffers. And the thing that goes hand in hand with that is not only can you not measure the latency in a realistic way, you actually can't build an application that has low latency if the APIs don't support visibility into that. So Bob was working on this enhancement. I told him about TCP not sent low watermark. He used that on the Mac, and it eliminated this excess buffering, and he got really good measurements. And then he tried to do the same thing on Linux, and it didn't work because Linux has a socket option with the same name that doesn't do the same thing. So let's not repeat that mistake, and let's actually agree across platforms that will have consistent behavior. I mean, it doesn't have to, it may not be identical. Different Wi-Fi, you know, Wi-Fi 4, Wi-Fi 5, Wi-Fi 6, they might have different behaviors, and different vendors, Wi-Fi chips may have different vendors. So it's never going to be perfectly the same, but we should at least have a common approach to what we're aiming. Sorry, that was a long answer.
Thanks so much.
All right, well, thanks for listening. Oh, we have one more.
John, do you hear me, by the way?
Hearing you now, yep.
Yeah, great. And I really support this work, and I actually got questions around this when working with other externals around the L4S project that we were running on. And it was then I was suggested this low F4.
I'm sorry, I'm having a hard time understanding what you're saying. Can you maybe say it a bit slower?
Yeah, okay. I'm too fast speaker. Maybe put it short. And you talked about Wi-Fi aggregation in the transmit path, and 5G has roughly the same properties. And the question is perhaps, is there a benefit for the application to somehow know if the socket becomes idle frequently, and then you can kind of add more so kind of time to fill up the buffer.
I moved to the audience mic because now I'm on the right side of the speakers and I can hear a bit better. The acoustics on stage are not good. I think that's a good suggestion. We should maybe discuss it on the list. Right now, standing here, I don't want to try to design that. I think the goal of this is that the socket should never become idle. If you've got an application that has got data to send, whether it's video conferencing or screen sharing or a game or whatever, if there's capacity available, I think you should always be using that to do useful work. So if the socket becomes idle, something has gone wrong. If it happens very occasionally, then I'm not going to lose sleep about it. But if it's regularly becoming idle, then either the application set its replenish time too low, or the network code is miscalculating its estimate. And the thing I want to remind everybody is, going back to my example, we had 2 whole seconds worth of buffering, which made for a horrible user interface. If we can cut that down to a 1/4 second, that's still quite a lot of buffering, right? That's still plenty to keep the output busy, but it's 8 times better than it was. So when we're starting at a position that is so bad, we don't need perfection to be an awful lot better than that.
Thanks.
Stuart, I have one last question. So what's the next step for next IETF? Are you going to have a BOF, or are you going to do other stuff?
So next steps are, hopefully people will engage on the mailing list, we'll have suggestions, we'll revise the document, it's in GitHub, people can comment on the mailing list, they can file issues, they can file pull requests. And between now and July, we will decide what to do. We could do a BOF for a working group just for this. We could decide it belongs within transport area. For now, I'm trying to focus on the technical subject matter, because we could easily get derailed in the politics of where does this belong. So at least for the next month or 2, I want to focus on advancing the draft. Once we have some concrete proposals in the draft, then I think is the right time to start the politics. And I actually have no opinion about that. I will solicit what other people think, and I will try to be a facilitator for whatever the consensus is. And remains to be seen what people want to do. So anybody who has an opinion, please join the mailing list and say so, because that's how we'll make the decision.
Thank you. Any more comments? Okay. Thank you, Stuart. So we still have a time. So maybe Michael?
Yeah. So we had the last presentation gave an intro in looking at BSD sockets, and that's what I'm also want to do. The background is I looked at the FreeBSD behavior of the close call. And the general behavior is if you use the close call in combination with the socket option SO-Linger, you can enable this feature and set an amount of time. It's n seconds. And when you call close with the socket option enabled, close will block for up to n seconds. And what this blocking is about, close will return when the fin is sent out and act by the peer. So the sender can control whether all the data has been transferred to the receiving TCP implementation. And if this is not happening, so the fin is either not sent within this amount of time, or the ACK is not being received, then close returns -1, and the variable RNO is set to E again, or E would block. And this is done by multiple implementations. You find this in man pages, you find this in some sort in POSIX text. And that's not the discussion point. In Unix network programming, in the book, there is one section which describes pretty well the high-level concept of this Linger option. The basic principle here is that a successful return from close with the SO-Linger option set only tells us that the data we send and our fin have been acknowledged by the TCP peer. This does not tell us whether the peer application has read the data. If we do not set the SO-Linger option, we do not know whether the peer TCP has acknowledged the data. So It's about knowing that the TCP stack of the peer received our data. And the question I have is, how should handle close the case where during its blocking, a reset is received? Or during this blocking, the TCP connection terminates because of excessive retransmissions. In BSD, close returns 0 and says everything's perfect. And I think this is wrong. And I would like to know how other implementations do this, like Linux, macOS, Windows, whoever implements BSD sockets, because I think it's important to know what other implementations do and what they should do. Any feedback on this?
Any comments?
I can't work the thing. Martin Duke, Google. Since no one who knows anything is in the queue, I'll just say I agree with you. I think it should not return 0 in that case. Just by the way, based on the documentation that you cited, that seems just wrong.
This is Yoshi. I also agree not return 0. And by the way, this might be off topic, but what's the benefit to specify non-0 for n? So I usually specify n equals 0, and because I want to reset the connection very quickly. But I never use n equal 1 or n equal 2 because I don't know what's the benefit of it. Which kind of situation we want to use this kind of n equal 1 or n equal 2? That's out of my curiosity. Sorry.
So I think you want to know whether the handshake, whether the data is actually received by the peer. You don't want to send anything anymore. You could send shutdown with shut WR to trigger the stuff, but
then why you have to set time limit? 1 second or 2 seconds?
I'm not the one, I'm just looking at the service being provided. I'm not sure about the consumers of the service.
Yeah, I just out of curiosity, why we need to do this kind of thing. That's all.
Richard, so do you expect this to be an addendum to the current TCP standards document to specify the SO linker, which we've had the discussion around APIs previously? Or is this like side work that is just...
This is just trying to find people who can answer this question in some way. The TCP spec does not specify a BSD socket API. The close call there is not the close call here. The close call in the TCP spec corresponds to the shutdown shut WR call in the socket API.
Yeah.
So this is not related to an RFC.
Just curious if you want this to be adopted as some kind of work item or...
Not right now.
You should come here and discuss this in the hallways next time.
Yeah. Thank you.
Okay. Any other comments? Okay. Nothing. Okay. Then we consume all agenda for today. Thank you so much for your attendance. So this concludes the TCPM working group meeting. Thank you so much.
And thanks for taking notes, Richard.
No.
Bye.
Bye.